In pretty much any company, there's that one person, the guru, right? The one who just knows everything. But what happens when they're not around? Well, a fascinating new study has an answer. What if you could actually turn their expertise into code? Today, we're going to break down exactly how they pulled it off.
I mean, just think about it. What if you could actually bottle an expert's brain, all their intuition, their gut feelings, those years and years of experience, and just pour it directly into an AI? That's really the big idea we're talking about here. Building a system that doesn't just crunch numbers, but actually thinks like a seasoned pro.
But first, why is this even a big deal? Why is it so important? Well, it all comes down to a massive problem that tons of organizations face, and the researchers have a name for it: the expert bottleneck.
I'm sure we've all been there. You know the person I'm talking about, the one guru who knows everything. And when they're swamped or maybe on vacation, super important projects just stop. They grind to a halt. This total reliance on just a few key people, it slows everything down and makes it almost impossible for a team or even a whole company to scale up. And look, the stakes here are incredibly high. The source paper puts it really well. This isn't just some minor inconvenience. It can lead to missed deadlines, burning through cash, and in some fields, yeah, even catastrophic failures. All that knowledge locked up in one person's head becomes a single point of failure for the entire team.
So what's the solution? How do you fix it? Well, the researchers came up with this brilliant, really systematic way to tackle it. Build a digital version of that expert, an AI that doesn't just follow basic commands, but actively uses expert-level knowledge to get the job done. And the framework they came up with? It's actually elegantly simple. It's just this 4-step loop. First, you interview the experts. Then, you implement their knowledge as rules for the AI. After that, you test the results to see how it did. And finally, you iterate. You go back and refine the system over and over. It's a really practical blueprint for turning all that human wisdom into actual working code. Okay, so during those interviews, they discovered there are really 2 different kinds of knowledge they had to capture. First, you've got the explicit rules. These are the clear, if this, then that kinds of logic that are pretty easy to write down. But then you have the really hard stuff, the tacit principles. This is the expert's intuition, the art of their work. Like knowing exactly which visual cue is going to best communicate a specific insight. The AI had to learn both. So here's a little peek under the hood at the AI's brain. When a user makes a request, this classifier thing acts like a traffic cop, figuring out what the user really wants. It then pulls from a whole library of these expert rules and combines that with the creative power of a large language model to spit out the final code. It's a super smart system that knows exactly which tools to use for which job, just like a human expert would. All right, so the theory sounds solid, but does it actually work in the real world? To find out, the researchers set up a head-to-head showdown. In one corner, a standard AI that only has access to the basic documentation. And in the other corner, their new digital expert, armed with all that incredible captured knowledge. Let's see what happened. And wow, the results are just striking. On the left, you see the standard AI. It basically produces a useless scatterplot. It's just a mess. But on the right, the digital expert applies a simple rule it learned from a human. Use solid lines for data that's stable and dashed lines for data that's not. Instantly, the chart is readable and actually tells a clear story. Big difference, right? Let's look at another one. The standard AI on the left gives us a plot that's, technically correct, but it tells us absolutely nothing useful. The digital expert on the right, though, it knows to use things like color and bubble size to represent different variables. And just like that, it visualizes these complex trade-offs between mass, cost, and performance. You can see the relationships immediately. And one last example here. Look at the standard system on the left. It's just a tangled mess of lines. It's almost impossible to read. The digital expert on the right, however, knows to automatically highlight the single best design in yellow, making the most important takeaway jump right off the screen. I mean, it is a night and day difference in clarity. So, yeah, the visual evidence is pretty overwhelming. But the researchers didn't just stop there. They wanted hard data to quantify just how much better their digital expert actually performed.
206%. Just let that number sink in for a second. 206. According to a panel of human experts who judged the outputs, the digital expert's work wasn't just a little bit better, it was over 3 times better on average. That is a massive, massive leap in quality.
And this bar chart really puts that number into perspective. So, on a 3-point scale, the standard AI's output was rated, well, it was a pretty dismal 0.85. The digital expert, on the other hand, scored an average of 2.6. It was consistently delivering expert-level quality every single time.
And it wasn't just about the scores on a chart. Real experts confirmed how good this was. One simulation specialist had this to say about the AI's work, praising it for getting everything right, from the color choices all the way down to the line types. In other words, it produced what they considered a true expert-level output.
So what's the big takeaway here? What does all of this mean? Why does a system that makes better charts actually matter in the real world? Well, it turns out it's about something much, much bigger. See, this framework is about way more than just data visualization. It's really a recipe for democratizing knowledge. It allows, say, a junior engineer or really any non-expert to produce results that would normally take years of experience to achieve. It breaks down those knowledge silos and frees up the real experts to focus on the next generation of problems, instead of just answering the same questions over and over again. And that leaves us with one final provocative question to think about. In your world, in your industry, what crucial knowledge is locked away in the mind of an expert, just waiting to be automated and scaled up for everyone? Because as this research shows, bottling that expertise is more possible right now than it has ever been before.